Hello everyone, good evening we enthusiasts. Welcome to the next session and a very special session with me, Shreyas, your master teacher for physics, going live at Vedantu on your very own channel, We Enthuse. How are my minions? How is everyone? Hello Wiki channel, Albert, Pravenchi, Suji, Priyanka, Dhanush, Kaushik, Nadeem, Pravenchi, Vishnu. Welcome Kaushik, Kirito, Yalni. Welcome aboard everyone. I know you guys are very excited for today's session. And before we begin, let me quickly introduce myself to all the new friends that you're going to make out here today and all the new minions that I'm going to receive on this very own channel of yours. So guys, this is Shreyas here and I have been teaching almost for a decade and I have been coaching students for KVPY, for IIT JEE, for NEET, and you name any exam for engineering entrance test, I have coached the students. And the good thing is the students are not just mentored under me. Many of my students have cracked the JEE exam, have cracked the KVPY exam, have cracked the Olympiads, have cracked the NEET exam, and they are right now in IITs, and many of them have even graduated from IITs, NITs, and all such prestigious institutes in our country. And believe me, if you stay tuned, if you follow my advice, you will be there, and when you look back at this, you will feel proud that you studied under me, hopefully. Hello Teface, hello Sanjeevni. Hello everyone, hello Nitish, hello Nirupam, hello Manoj, hello Uncharted, hello Dhanush. Yes, so maybe I won't be able to take all the names, but as and when you keep chatting, I'll definitely keep taking your names. So keep the chat box alive. Make sure that the josh never dies down. And guys, if you still want to get in touch with me, you know where to contact me. That's on Instagram, Shreyas_Vedantu. That's my Instagram handle. So do not forget to check it out and check out all the cool, amazing stuff I have put out there. And before we begin, do not forget to hit the like button. Yes, make that gray button blue. Come on, I hope you have smashed that like button and made it blue already. And if you have that subscribe button which is red, make sure you make it whitish gray. Okay, because only then you will be getting all the important updates from our channel. And this is the third important thing which you should do. Never ever stop the joy of sharing. The joy of sharing is very different. So share it with your friends, family members, whosoever will benefit from this particular channel and videos. So a quick look at this week's timetable. So today we are seeing all the formulas for 11th. And some of you 12th standard students might be wondering, sir, what about 12th? Well, here it is. Look at this, Saturday. Complete 12th revision just like today. Complete 12th revision on Saturday. And tomorrow it's going to be a special occasion, Republic Day special. So I'm going to conduct a special lecture tomorrow. Stay tuned. The link, everything will be put up on this channel in some time. Wednesday, we are going to see thermal physics one shot, calorimeter and KTG. They are very important, easy chapters, but needs to be done. And previous year question paper discussion, 2020 JEE Main's paper discussion will happen on Thursday. All three of us are going to discuss the same paper. I'll be discussing physics, Shimon sir will be discussing maths, Wazim sir will discuss chemistry. That's what we are going to do. And Friday, obviously, remember last lecture I couldn't conduct because, of some technical issues. So Friday, you're going to have a marathon session on optics. So keep that in mind. All right? Yes. So I hope you guys are all ready. Drew, the KVPY class lecture are not completely done. Like you can see, there are 2 more classes, including today's, and there are a lot of lectures in the playlist which you can see. Thank you, Chandresh. Hi, Apna. Hi, Sakib. Hi, Bhutinath. Sorry. All right. So let's begin. Are you guys ready? Are you guys ready? Are all the minions ready? Minions, come on. Is the Josh high? And make sure you stay tuned till the end and make sure your notebook is on the side. Keep writing down the formulas as and when I write it down so that it gets imprinted in your head. It's ingrained in your head. It does not get out. Ready for this awesome session? I hope you have already smashed the like button and the newcomers out here have already subscribed to our very special channel, We Enthuse, with your host Shreyas and your master teacher Shreyas out here. All right, so let's begin. So what do we start with? It's not like I have to go chapter wise. You will see I'll be linking different chapters today. And first thing I'm going to start with is relating translation and rotation. Very important, start noting these things down. So you will see a lot of formulas in translation and rotation are related to each other. Number one, see, you have position, which is given by the symbol X. In rotation, you have angular position. Position is expressed in meters. Angular position is expressed usually in radians. Where is he? X. X position on the number line, or where is he on the Y number line, or where is he on the Z number line. So you can have X, Y, Z coordinates. Similarly, angular wise, where is he with respect to a reference line? He is at 30 degrees. Oh, he is at 60 degrees. Oh, he is at minus 20 degrees. So it could be anything, guys. So theta is the angular position. Then you have displacement. So this is also expressed in meters. Here you have delta theta, which is also in radians, and this is called angular displacement. I might not be writing down everything, but in your notes, make sure to write this down. Delta x, final minus initial is displacement. In angular terms, final angular position minus initial angular position is angular displacement. Next, velocity. Velocity is nothing but delta x by delta t. Here you have angular velocity is delta theta by delta t. Now, if this is average, then this will be delta, if this is average. But if this is instantaneous, then instead of delta, it will be derivative. So it will be dx by dt. Same thing, instantaneous angular velocity will be d theta by dt. If it is average, it will be how much angle you covered in how much time, and this will be obviously in radians per second. Like so, over here it will be in meters per second. Is that clear? Everyone understanding this? Everybody understanding this? Hi Rupam, welcome. Yes. So don't worry Sanjay, today you will have a complete revision of all the formulas out here. Okay. Kiran, it's not just for KVPY. You can use this entire lecture for your JEE Mains preparation. First, second, third attempt doesn't matter. This is also for the JEE aspiring students. Keep this in mind, because formulas will not change. Omega will not become something else for JEE, right? It will remain the same. So keep this in mind. So though I have labeled the lecture as KVPY, it's useful for JEE as well. Keep this in mind. Okay, the next thing, obviously, acceleration is change in velocity upon time taken to change that velocity. Here you have alpha, and alpha is nothing but change in angular velocity upon the time taken. This is in meters per second square, and this is in radians per second square. Okay, this is another important formula. Next important formula, mass. Mass is inertia in translation. In rotation, it is moment of inertia, and the unit is kg meter square. This tells you how much resistance you have to change the state of motion. This tells you how much resistance you have to change the state of rotational motion. So to rotate something, how much resistance it experiences is called as rotational moment of inertia, or just moment of inertia. Beware, the formula for this is sigma mi ri square. So you take each mass into distance square, second mass distance square, third mass distance square. Add them up, you get the moment of inertia of all the bodies. I'll be giving you a list of all the moment of inertias and teaching you ways to remember them as well. Stay tuned. Okay, next, very important stuff. Length of an arc, okay, this is the length of an arc, is equal to r into theta. This is nothing but angle subtended. Angle subtended. Now, the next important formula over here is the velocity along the circular path is r into omega. Look at this. Divide length with time, you get velocity. Divide angle with time, you get angular velocity. I hope you can see that. So velocity along a circular path is r omega, and divide this with time or differentiate this with time. What do you get? You get tangential velocity is r, and omega with time, how does it change? Alpha. So you can see all the three relationships related to each other. Sunita, I'll be covering optics in 12th standard. Don't worry. Okay, I hope this is clear. Yes, very, very important. Yes. Okay, cool. So next up, force. Equivalent of force is torque, and the definition of torque is R cross of F. Very important. Force is also a vector quantity, but the equivalent of force is torque, which is R cross F. Just like you have F is ma, in rotation you have torque, net torque is equal to I alpha. So this is net force is mass into acceleration. You have net torque is I into alpha. That's number one. Next thing, momentum is mass into velocity, correct? The equivalent over here is angular momentum. So the equivalent of angular momentum, the equivalent of momentum is angular momentum, and that is I omega. But remember, this formula is used for rigid bodies. Rigid body, as in like you have a sphere or a cone or a plate which is rotating, then the angular momentum is I omega. But if it's a point mass, then which formula do you use? mR cross VCM. This is the formula that you will use when it's a point mass, or you are talking about center of mass of a body or something like that. So this is for point masses. This is for a body which is rotating about an axis. Is that clear? I hope this is clear, everyone. Take face, I'll be maintaining this speed because we have to cover a lot of things, and at the same time people are also making notes. I would also advise you to make notes. Even if you feel the formula is known or simple, please make notes. That way you will be able to remember these things. No, Asta, if you want, you can skip SHM, but I would advise not to skip much. Provided you have good strong hold on other topics, then you can skip SHM. Otherwise, don't skip it. And try to see whatever formulas I give today, maybe it will help you. Okay, next up, after momentum, force, etc. Okay, next up, you have impulse, which is change in momentum. Okay, this is impulse, which is change in momentum. You have angular impulse, which is change in angular momentum. Remember that. Just like change in the momentum of a body is impulse, change in the angular momentum of a body is angular impulse. Keep this in mind. Last stuff over here, if acceleration is constant, then V is u plus at. All right, V is u plus at, S is ut plus half at square, and V square is u square plus 2as, and displacement in nth second is u plus a by 2 into 2n minus 1. These are the formulas for translation. This is displacement in the nth second. Same thing in rotation. If alpha is constant, keep this in mind, then you have final angular velocity is initial angular velocity, which is omega I plus alpha into time. Very, very identical. And same formulas are there even in rotation, like angular displacement is initial angular velocity into time plus half alpha t square. Third equation will be omega final square is initial angular velocity square plus 2 alpha into delta theta. Same thing. These kind of questions have come in the JEE KVPY exam, so that's why I'm telling you all this. Displacement in the nth second for rotation will be initial angular velocity plus, instead of a you will have alpha divided by 2, and instead of, you'll just have 2n minus 1. Is that clear, everyone? Very good, very good. VK channel noting down. So gamers zone, ideally you should not skip any chapter if you want to clear KVPY. Max to max 1, that 2 you can skip, but 1 or 2, not more than that. Okay gamers, but that too provided you are very good in other chapters. And like you have seen in many of my sessions, many questions come combined. 2-3 chapters are combined. So you cannot exactly say that this question is from this chapter. Sometimes 2-3 concepts get involved in one question. So that's when it becomes difficult. Okay. So Yashvana, don't worry. All these things you can replay again. Don't worry. Okay. Shall we go ahead? Yes, magnetism is also important, Asta, and I have covered a lecture on that as well. Very good, Saurav. Okay, chalo. Now, before going to the next problem and next set of formulas, I am going to cover all the chapters today. You need to maintain high energy, you need to maintain that patience, you need to maintain that strength and stamina. Let me tell you a very important announcement for tomorrow. Most of you already know it. Tomorrow there is going to be an all India JEE mock test. Yes, there is going to be an all India JEE mock test for free. You will get national rank. Not just that, you will also get a discussion session along with it, and it is going to be conducted tomorrow. So there will be tips, tricks session on account of Republic Day, and we are going to also have paper discussion, and it's an all India mock test, especially for the 12th and the dropper students. So do not forget, guys, the link is in the description box today. You can see it in the description box. So Bhanu, maybe if you do not find it in the playlist, just go to past videos, you will find it, don't worry. And another important thing is the crash course, which is going to start on 28th. A new separate batch of crash course on 28th of January, and after that again you'll have to wait for a few more weeks before the next batch starts in. What is this crash course all about? Well, it's for all the aspiring students of JEE Mains 2021, and best part, these are not one-sided lectures, these are two-sided lectures. As in, you know, it's like an interactive session. Number two, there are two teachers together who are conducting the lecture. One is the main master teacher who is teaching you. Second is a teacher who is going to solve all your doubts simultaneously in the class. And after the class, you get a doubt expert who will solve your doubts real time, so that in this limited time that you have, no doubts remain in your brain. That's very important. And there are going to be almost like 15 or 20 test series, which are very important, because these are not just tests with some solutions which will be handed over to you. No, there will be discussion sessions, live discussion sessions, not recorded, live discussion sessions. But yes, you can play it again and again if you feel that you had difficulty in some part of the problem. Also, all the lectures that you get, all the 45 sessions that you get recorded, so that even after the class, or by chance, let's say you miss a class, you can watch the replays again and again. And last thing, Pulkit sir, Anand sir, and many other master teachers are going to give you special strategy sessions for cracking JEE Mains 2021. So guys, listen in, this is very important. And all this right now is at a 30% discount. That is huge. Mega sale, Republic Day sale. Usually it used to be 20% discount. Those of your regulars know it already. So instead of 10,000, you will get 7,000 rupees. All right, that's what the course price is right now. 30% off on the original price. So go ahead, check it out, because last 1 or 2 days, and that's it. Again, you'll have to wait for a longer time for getting enrolled into the crash course. Next thing which is important is this discount will not be valid after a time. You know that. This is a seasonal sale which goes on. So the link is below, and use the coupon code SHCC21, which is very important for you to note down, or you can pass on the link to your friends or your family. I hope this is clear. So Uncharted, if you want to give, no problem, you can definitely give. Yes, you can do that. And guys, this is a Republic Day sale, so do not forget. Again, the discount is going to go back to 20%. You know that. If you have been there for Christmas, New Year, Diwali, you know it is going to go back. So guys, do not hesitate to join in right away. Yes, very, very important. Cool. So let's get going. Thank you, Ansu, and thank you, everyone. Let's get going to derivatives and integration in one slide. All right. First, position, velocity, acceleration. Remember this chart. This will always help you for solving derivatives related problem. So if position is given, how do you go to velocity? Differentiate it. Derivative of position gives you velocity. Derivative of velocity gives you acceleration. And the exact reverse of derivatives, which is anti-derivatives, what is it called? Integration. So integration of acceleration and integration of velocity gives you the upper one. So integration of velocity gives you position. Integration of acceleration gives you change in velocity. So, but be careful. When you integrate, there will be a constant of integration, or you might have to put limits. If you put limits, don't put constant. If you put constant, don't put limits. That's how things work. So to go from acceleration to velocity, again integrate acceleration, you will get velocity with or without a constant, depends on if you put the limits or don't put the limits. Now, which are the formulas which you should remember? Come on, let's quickly revise. Yes, for derivatives. Derivative of x raised to n, guys. Come on, what is the derivative of x raised to n? It is nx raised to n minus 1. This is one formula which you should remember. Okay, then derivative of Derivative of sine of x. What is the derivative of sine of x, guys? Come on, it is cos of x. So if somebody asks you what is the integration of cos of x, the answer will be sine of x. Understand that. It works both ways. Derivative of sine is cos, integration of cos is sine. Same way, derivative of cos of x. What is it? Derivative of cos of x? It is minus sine x. Be careful. Okay. And derivative of constant is 0. Next, derivative of e raised to x. Very important function is only e raised to x. Very special function. Derivative of e raised to x is e raised to x. And one last function which is very important. Derivative of ln x is equal to 1 by x. So remember these basic formulas at least. If you want to remember more, I have put it up in the extracts, and plus you can also find it in the maths book. But these are the most important formulas which you should know for sure. Derivative of log of x is 1 by x. Derivative of e raised to x is e raised to x. Sines is cos. Constants is 0. Cos is minus sine. X raised to n is nx raised to n minus 1. Cool. So biologists, can you score in KVPY if you solve all the papers? I will reply to you, biologist, if you first of all apologize for spamming. If you say sorry and then ask me, then I'll definitely answer, but don't post the question so many times. Don't spam. Yes. Now, next up. Remember, when you go from position to velocity, graphically, it's the slope of position versus time. Slope, as in, if you draw a tangent out there, if you draw a tangent for this graph out here, okay, the tangent slope, which is tan theta, that gives you velocity, and slope of velocity gives you acceleration. Same way, if you go reverse, velocity's area gives you displacement, not position. Be careful. Velocity's area gives you displacement, which is delta x. That also means area under acceleration does not give you velocity. What does it give you? Change in velocity. This is where many people go wrong. People think it is velocity. Guys, be careful. It is always change in velocity. No problem, biologists. So you can score really well if you solve all the KVPY papers, including the JEE Mains paper. Yes, that is the right strategy, provided you know the basic concepts properly and the formulas. Okay. Now, vector subtraction, addition, let me teach you some tricks. Let's say this is vector C, let's say this is vector A, let's say this is vector B. Example. Let's say this is angle beta, let's say this is angle alpha, let's say this is angle gamma. Example. Now, if, for example, C vector is A vector plus B vector, then arrow marks wise, it should be something like this. This is A vector plus B vector is equal to C vector. Look at the arrow marks, very, very important. A vector plus B vector is C vector. Then if I ask you what is the angle between A vector and B vector, please do not say it is gamma. Angle between two vectors is when the vectors are aligned together with tails or with heads. See, the head of A is with the tail of B. So that is not how angle is defined. Slide vector B so that B's tail merges with A's tail. Then that angle which you get, this is the angle between the two vectors. Very important. So the angle between the two vectors A and B is when you have their tails aligned or their heads aligned. Very important. So in this case, theta is actually 180 minus gamma. Is that understood, everyone? Angle between the two vectors. Next, which rule you can use is called as, there is another important rule which you can use. It is sine rule. Sometimes people also call it as the Lami's theorem. So A upon sine alpha will be B upon sine beta, which is C upon sine gamma. Very important formula which will be helpful for solving problems where you know two angles one side or two sides one angle, etc. So you can find out the third side just by geometry using this rule. And another important formula, which is this: C square is A square plus B square plus 2AB cos theta. This is the usual formula which you learn in vectors. But in maths, you study this. C square is A square plus B square minus 2AB cos gamma. Now why are these formulas different? Because if you substitute theta as pi minus gamma, then this is what you're going to get. Think about it. Theta, if you substitute it as pi minus gamma. So if you are taking the internal angle, then it is minus. If you are taking that external angle, then it is plus. Keep this in mind. Is that understood? Yes, very, very important. The resultant vector formula. You can find everything else from this. Yes. Okay, shall we go ahead? Shall we go ahead? Okay, so these are some important pointers in vectors. Next, relative velocity. Now this is a common misconception which many people have. And that is this. Let's say you have Pandu. Okay, let's say you have Pandu. And let's say over here you have Champa. Okay, so oops, I forgot her lipstick. Okay, so this is Champa out here. And let's say over here we have Laddu. Okay, so remember this. If I tell you, one second, velocity of Pandu with respect to Champa, what is the formula? Then I can write it like this. It is velocity of Pandu with respect to Laddu minus velocity of Champa with respect to Laddu. So this is very important. This is vectors. This can be minus, this can be plus depending on the sign of this term. Understand? So velocity of Pandu with respect to Champa is velocity of Pandu minus velocity of Champa, provided they are all measured from the same thing. What is it? With respect to Laddu. Please keep this in mind. With respect to the same term. This is very important. So same frame of reference. Then use vector subtraction. But let's say you want to change the frame. Then what do? Velocity of Pandu with respect to Champa plus velocity of Champa with respect to Laddu is velocity of Pandu with respect to Laddu. All I have done is taken this term and brought it towards this side. Take this term and bring it towards this side. So this is when there is change of frame. Look at this. There is Champa frame, Laddu frame. You can see that there is a change in the frame. Then use this formula. But you can always stick to this formula and get to this. So either remember this or remember both, whichever you are comfortable with. But remember at least one of them. At least one. Best will be if you remember both. Now this is a very easy way to remember. See, I'll tell you how. PCCL. Do you see that? PCCL. So combine both of them together and cancel it. What is remaining? PL. That's what is remaining. So this is an easy way to remember this. I hope this is clear. Is that understood? Everybody loving this revision? Shall we go ahead, guys? Come on. Okay. Chalo. Let's get going. And this can be used for rain man problems, riverboat man problems, etc. Clearo, very good. Fida Krito, very good. Yes, VK Bhakti, very good. Are there 11 concepts also in KVPY? Yes, Bhakti, obviously. Even for SX, there will be 11 standard concepts. So Shweta, why don't you message me on Instagram or put up a comment after the video? Definitely I'll help you out for JEE 2022. Very good gamers, Priyanka Dhruv, Asta Garv, Uncharted, Bhakti. Very good. Okay. So Shweta, why don't you please ping me on Instagram? My handle is already mentioned, Shreyas_Vedantu. I'll definitely help you out. Okay. Chalo. Next, Newton's laws of motion. Quickly, let's revise. First law, body continues to be in rest or motion unless and until an external force acts on it. Now, very important to note for first law, remember this. A lot of people do not pay heed to this. If force is 0, does not mean there is no force. This means net force is 0. Very important. Net force, if it is 0, then acceleration is 0. That means velocity is not 0. Velocity is constant in magnitude as well as direction. Both. If force is 0, magnitude will be constant, direction will also be constant. That is first law. Second law, the force which you apply, if there is some external force, that changes the momentum, and that is mass into acceleration. Now remember this, whenever you draw a free body diagram and you find this is the force in x direction, okay, this is the force in y direction, and let's, after resolution and splitting of vectors, and you get the acceleration here, and then what you do is split the acceleration as well. So you get some acceleration in x and some acceleration in y. Remember, you can write force in x is mass into acceleration in x, and force in y is mass into acceleration in y. If in one direction there is no acceleration, then the net force in that direction will be 0. Is that clear? So this is what you should keep in mind. So P is momentum, that is rate of change of momentum, is mass into acceleration. Third law, every action has equal and opposite reaction, and everything follows this, including charges, magnets, etc. There have been questions like this even in KVPY, where there was a small charge here and there was a big charge here. So guys, think and tell me, who applied more force on whom? Did one apply more force on two, or did two apply more force on one? Mukundan, even if you're late, don't worry, just join in. Also during the live class, you can rewind back the class and play it up at 2x speed and you can catch up. Alright, did 2 apply more force on 1 or 1 apply more force on 2? Shreyas says 2. Guys, the answer is not 2, the answer is same. Think about it, Newton's third law. Every action has an equal and opposite reaction. There is no ego saying, oh, you are big, so you apply more force. Oh, I am small, I'll apply less force. No, both will apply same force. Very, very important. In fact, there was one more question many years back. There are two people and they are playing tug of war. They are playing tug of war, and this is the winner and this is the loser in the tug of war. Who applied more force on whom? The answer is both applied same force on each other. Remember that. That's Newton's third law. One person loses because of less friction or less grip on the ground, not because he applied less force. Very, very important. Okay. So this is Newton's third law. A quick revision of all the forces that we have. Spring force, Kx. Is this negative sign important? No. What does this negative sign say? That the direction is opposite to the pull. If you extend it, spring force is going to push you back. If you compress it, it's again going to push you back. So it's always opposite to the elongation or compression. So magnitude wise it is Kx. Do not remember that minus sign. It's not relevant. Okay. And it is proportional to x. K is the spring constant. If K is more, it's more stiff. Next force, weight. Weight is always constant near the earth's surface, and it is always going to be mg. Okay, very important. Tension. It's the force in the string. When you pull the string more, there will be more tension. Keep one more important thing in mind. In a massless string, the tension is same throughout. In a massless string, the tension is same throughout, and whenever you have a pulley problem, something like this, okay, and this is a massless pulley, mass is 0, and if you have string here and here, then if this is tension T, this is tension T, this is always 2T. Keep this in mind. Okay, TT will become 2T. Okay, and for a massless string, tension is same throughout. Even if it goes like this, like this, like this, doesn't matter how many pulleys are there in between, this tension will be same. Keep this in mind. Okay, last one up, normal force. It's always perpendicular to the surface in contact. And if normal is 0, if there is any question which says it lost contact, then first thing you should do, make the normal force 0, guys. Make the normal force 0. Okay, cool. That is what is important. Okay, next up is friction. Remember, if there are two surfaces which are not moving relative to each other, then the friction acting is static. But they actually move, then the force is kinetic. So even if my both hands are moving right now, but relative to each other they are not moving, then the force between them is static. But if my one hand is stationary, other hand moves, then the friction is kinetic in nature. So there are two types, static and kinetic. So static friction opposes the tendency to move, but kinetic friction actually opposes the relative motion. That is what you should keep in mind. And the force exerted due to friction is always mu into n. But for static, that is the maximum force that it can hold through. So understand, if you are talking about static friction can be anywhere between 0 and Fs max. This value Fs max is mu into n. So your static friction can be anywhere between 0 and Fs max. You can see that. After Fs max, it suddenly goes down to kinetic friction, and kinetic friction is mu into n, and it is a constant. Like you can see, Fs can be a variable. Fs can be a variable. Kinetic is constant for a given normal. Okay? Very good. Very good. Very good. All right. I hope you have noted down all these things. And one more important thing, the slope of this graph is 1. This angle that it makes is 45 degrees. It's a self-adjusting force. If you apply more force, friction will increase. More force if you apply, friction will increase. As much force you apply, friction will increase that much. So the slope is 1 or angle is 45 degrees. Keep this in mind. Okay. Cool, 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 cool. Asta, Princey, very good. Yes. Very good, Balaji. All right, all right. I hope you guys have noted down so many formulas. Don't give up so easily. There is a lot more to come. But remember guys, in today's lecture, all the formulas, important formulas will be covered for your KVPY as well as JEE. So guys, even if you have joined in late, it's okay. You can always watch the replay of the missed part or the missed session. Now watch it live. Only then you will have the josh to watch the remaining part as well as the part which you have missed. Okay. Next up, work power energy. Work is force into displacement but with a dot product, Fs cos theta, and if the force is variable, integrate it. So remember, integration always comes with area. That means area under force versus displacement gives you work done. Okay, keep this in mind. Next up, power. So by the way, work's unit is joules or ergs. So rate at which you do work, how quickly you do the work. If you do the work slowly, power is less. If you do the work fast, the power is more. Rate of doing work, derivative of work gives you power, and it is also force dot product velocity. Keep this in mind. Keep this in mind. Kunal, more than the PDF, I would say yes, the PDF will also be provided, Kunal, and don't spam. That's number one. Number two, please keep making notes. Remember, if you just stick the PDF on your wall, nothing will enter your head. Please keep writing these things down. That's very important, Kunal. Okay? No problem, Kunal. Join in. Hello, Arushi. Welcome. Join in. Join in. Okay. Next, kinetic energy half mv square. Another important form. Many times questions come on this. Momentum square by 2m. P is momentum. Yes. This is also an important form. Many times you will see problems on this. V is velocity. Okay. And last up, work kinetic energy theorem. So whatever is the total work done, by all the forces, this is very important. This is not external work done. This is internal plus external. And if you have solved HC Verma objectives, you know this already. This is not external. Internal plus external work is final. Oops, I think this was a mistake. This should have been final minus initial, guys. Please change it. Okay. So if you want, I'll just put a minus sign over here because I cannot change the subscripts down. So it is always final minus initial. Remember. So the change in the kinetic energy is the total work done. Final minus initial kinetic energy. Okay. So very important for solving problems. This is a sure shot method which will not involve any confusion or any kind of visualization. Just follow this theorem for a work energy conservation problem. You will get the answer. Okay. Chalo. Let's get going to the next part. Next part is potential energy. Potential energy is the energy which is stored because of the way it has been configured. Remember, there is no true value for potential energy. You can take anything to be zero. Always potential energies are measured with respect to that zero. It can be positive, negative, more, less. What matters is always the change in the potential energy. So potential energy's absolute value has no significance because what matters is the change, and your potential energy depends on where you take zero. You can take anything to be zero energy. So for gravity, remember potential energy Potential energy of gravity is given by mg delta h. Change in the gravity energy is mg delta h. Change is what matters, and change in the spring potential energy is nothing but half k x square. X is what? The deformation. X is what? The deformation, half k x square. Remember this formulas, guys. Okay. Similarly, for electrostatic it is k q1 q2 by r. For magnetism it is very similar. For heavenly bodies, two masses spread apart with some distance, then it is for gravitational potential energy for heavenly bodies, it is minus g m1 m2 by r. Please note the minus sign, there is a big difference. Okay, so this is the minus sign. For heavenly bodies you will generally use this. G is gravitational constant, not that 9.8. Okay, sum of kinetic and potential, it's called mechanical energy, and that will be constant, not always, only in certain scenarios. Which scenarios? Only those scenarios where there are no evil forces. What are those evil forces? Friction, viscosity, drag, normal. These forces should not take away or do some kind of work. If these forces do not do any work, then only the mechanical energy will be conserved, not always. Please keep this in mind. Keep this in mind. Kinetic and potential is sum is basically the mechanical energy. Okay, let's go to circular. Okay, my good name. Well, I only have one name. I don't have a bad name or a evil name. My good name is Shreyas. Okay, cool. So Arushi, even if you are in 8th, you can watch this, but I'm guessing it's little bit early, at least like 2 years early for you, but it's okay. If you want to watch, you can watch, no problem. Okay, Carrie is live. Is this session have full class 11 formula? Yes, Carrie, just like the name goes. Yes, it is. Very important diagram for vertical circular motion. Already I gave you some formulas for circular motion. Now this is another important diagram. How tension changes with gravity, and how you will draw the free body diagram. Very useful diagram. Let this be there in your notes. Now what is more important is also the velocities required to complete the circle. Now first thing, if you have a rod, okay, if you have a rod and there is a bob attached. Who is this? Bob. Okay, now if you give him some velocity and if he is able to complete the circle, then at the highest point it will have almost zero velocity because the rod can never become slack, and this velocity, so that it completes the circle, is always root 4 GL. That is root 4 GL. Keep this in mind. But if you don't have a rod, you have a string. You have a string over here, but you still have that bob, and you want it to complete the circle, then at the topmost point the velocity won't be zero. In fact, the velocity should be root GR. Yes, the velocity at the topmost point for a string should be root GR. Keep this in mind. For a string it should be root GR, and that's why this velocity at the bottom should be slightly higher, and it will be root 5 GR. Actually it should be R or L, depends however you write it. Okay, so keep this in mind for completing the circular motion. Yes, Aman, KVPY SX will be conducted on Saturday. Complete revision of all the 12 standard formulas on Saturday. Okay, next up over here is, if you have a rod or a string, doesn't matter, if you have a rod or a string and you have a bob and you just want it to reach here, that means the velocity over here will be 0. Then the velocity which you need to give is root 2 GL. Only to go till here, and it will come back and again go till here. Semicircle. This is half a circle, guys. So this is root 2 GL, and it doesn't matter whether it is a rod or a string. If you want to watch the detailed explanation, I have created a playlist. It's in fact there in the past videos, how these formulas come, etc, etc. For today, we are just revising formulas. Keep this in mind. Okay, cool. Okay, next up, conical pendulum. Very important formulas. People ignore these formulas. Important formula. You have a pendulum which is going in the form of a cone. Angle subtended with the vertical is theta. Tension in that string is m omega square L. Very important. And the angle theta is such that cos theta is G divided by omega square L. Very important formula, guys. So keep this in mind. The angle depends on omega. If you rotate it more and more faster, then it will become wider. Theta will increase. Keep this in mind. Yes. Is that? No, for a semicircle, it is not root 4 GL. Meenakshi, if you have read it anywhere else, please understand it's wrong. For semicircle, it is root 2 GL. At the bottom you give root 2 GL so that when it goes there, it becomes 0. Again, root 2 GL, 0. For it to complete entire circle, then minimum speed at the bottom is root 4 GL for a rod, so that at the top it just becomes 0 and it is just able to come back again. Okay, cool? Yes. Yes, Carrie is live. I do remember you, Amal. Yes, I know you from this JEE B batch, my regular batch. Yes. Next up, banking formula. I will give you a God formula. After that, you will never question this. So guys, for banking, the maximum velocity is root RG tan theta plus alpha. You'll be like, sir, what is theta? What is alpha? Theta is angle of banking. Where is this banking angle given? Here, look at this. You'll be like, sir, what is this alpha? Alpha is such that tan alpha is mu. Remember, this is nothing but angle of repose. Angle of repose. Very important. That angle at which something just begins to slide. That is this formula. If you want, you can expand this and you will get it in your regular form. Use tan A plus B form. It will be tan theta plus tan alpha upon 1 minus tan theta tan alpha. It is your standard form then. Okay, this is very important. Next thing, optimum speed. For optimum speed, make alpha 0, no friction, less wear and tear. Rg tan theta, no alpha over there. That is optimum speed when there is very little friction, no friction actually, and there is very little wear and tear of the tires. And I have also given you the formula for V minimum. The least speed with which you can go is root Rg tan theta minus alpha, provided theta is more than alpha. So minimum speed so that you do not slide down. Very important. Another thing, this formula can also be used for a flat road. How? By making theta as 0. So if you put theta as 0, what will happen? Vmax will become root Rg, theta is 0 guys, tan alpha. But what is tan alpha? Mu. So it will become root mu Rg for a flat road. So understand this formula you already know. So this is a God formula which incorporates so many cases. Yes. Is that clear? Yes, I'm guessing that should be close enough, but you can definitely try harder. Definitely try harder. Don't stop over there. 70 plus is decent. Yes. Okay. So Ranjan, if you still have doubts, why don't you post it on Instagram or in the comment section after the session? Definitely I'll help you out, Ranjan, for sure. Don't worry, Ranjan. I'll help you. Just post it in the comments. Very important formulas. Take a screenshot. Center of mass. Center of mass. Center of mass. For sphere, center. Hemisphere, solid, 3r by 8, and for hollow, r by 2. Where is it measured from? From the bottom. Please be careful, not from the top. Solid cone, h by 4. Hollow cone, h by 3. How do you remember? Sir, I always get confused. Solid, hollow, I don't remember whether it was r by 2 or 3r by 8. So don't worry. I'll tell you what to do. See guys, for solid, because more mass will be there below, center of mass should shift down, right? Same thing for solid cone and hollow cone. If it's solid, it should go more below. So look at this. For solid cone, h by 4. H by 4 is smaller than h by 3. This is 33%. This is 25%. So obviously you can see h by 4 is smaller than h by 3. That's how you can remove that confusion. Okay, clear? Next up, solid cube, solid cylinder, that's at the geometrical center, cube, etc. Now this is very important. Sector and arc. If you have a sector of a circle, this one, a slice of pizza, if you have a slice of pizza which subtends an angle alpha, then the center of mass is somewhere here, and this distance is 2/3 r sine alpha by 2 into divided by alpha by 2. Okay, that's one formula. Arc of a circle, you eat the pizza but the crust of the pizza is remaining. Look at that, only the crust, that ending part, arc, is remaining. So then the center of mass is somewhere here, and this distance is given by r sine, same formula, just this 2/3 is not there. Keep this in mind. Keep this in mind. Yes, I just answered your question, I guess. Okay, so, okay, cool. Next, moment of inertia, ring, mr square, disk, mr square by 2, hollow cylinder is same as a ring, because when you pull the ring, it becomes hollow. Solid cylinder and disk, same formula, because when you pull the disk, it becomes solid cylinder. Okay, cool. Next up, rod, ml square by 12, where? At the center. Right angle triangle, very important formula, 1/6 mb square. B is the base and this is the axis. This is the axis, and you rotate the triangle like this. 1/6 mb square. Hollow sphere, 2/3 mr square. Solid sphere, 2/5 mr square. And obviously you should remember parallel axis theorem and perpendicular axis theorem. If you have a body and there is an axis which passes through the center of mass, then about any parallel axis, doesn't matter in or out, this parallel axis moment of inertia is ICM plus, you shift it by d, so md square. This is parallel axis theorem. Next up is perpendicular axis theorem. If you have a sheet like object only, then moment of inertia about an axis which is perpendicular to the sheet is, take two axes like this, let's say I call it Ix and Iy, then this moment of inertia is Ix plus Iy. This is perpendicular axis theorem. Cool? Great, great. Let's get going ahead. Guys, are you going to give up so easily? Are you tired? Are you tired? I am not tired. I am not tired. What say, guys? What say, guys? Are you guys tired? Shreyas, you can. Very good. You said you will crack essay. Very good. That's the spirit. Very good. Who and all are going to crack the KVPY examination? Tell me. Who and all are going to crack the KVPY examination? Who and all think that they will do better? They are going to put in full effort even if they feel that they are going to do pathetic in the examination. Are you going to give up so easily? Yes or no? Are you going to give up so easily? No ways, right? Yes. Full of energy. Very good. Pragya, please put up a comment or ping me on Instagram, Shreyas_Vedantu. That's my IG handle. I'll definitely help you out, because right now it might be slightly difficult to answer individual doubts, but definitely I'll help you. Very good. That's like my minions. Excelente, guys. Excelente. Very good. Very good. Drink water, guys. Even I am not drinking water and I'm full of energy. How can you be low on energy? Come on, let's do this. Let's do this. Momentum and impulse. Momentum is mass into velocity. Everybody knows. And momentum is always in the direction of velocity. Change in the momentum is impulse. I just told you. And very important, impulse is not just change in momentum. It's also force into time. And the area under force time gives you impulse. Keep this in mind. Area under force time gives you impulse. Integration of force versus time gives you impulse. Impulse is change in momentum. Momentum is mass into velocity. That also brings me to impulsive force and non-impulsive force. If a force suddenly changes in small time, a large change in momentum, impulsive force, like hitting a ball with a bat. Non-impulsive force, small force acting for a long time. You slowly pushing the ball and it gains velocity. Non-impulsive. Cool. Conservation of momentum. Is momentum conserved always? No. Like what? No. Yes, it is not conserved always. Then when is it conserved? Only when the net external force is zero. So that means even if there are internal forces, like you shoot a bullet, there is a force by the gun on the bullet. That is an internal force. That won't change the momentum of the system. External forces only can change the momentum of the system. Keep this in mind. Keep this in mind. Yes, Karan, magnetic effects are important, and I have done some questions on essay magnetic questions. Okay, essay related magnetic questions. You can check it out in the playlist or in the past videos out there. Cool. So, very important formulas. Elastic collision, energy is conserved. Is there something like a perfectly elastic collision? No. But is there inelastic collision? Yes. And is there perfectly inelastic collision? Yes. So, elastic, like a rubber band, energy is conserved. Inelastic, energy is lost. But momentum is always conserved, provided net force is zero. And remember, perfectly inelastic collision has equals to zero. Okay, that coefficient of restitution. What is it? Relative speed of separation. After the collision, how is the relative speed of separation? Before the collision, what was the relative speed of approach? Remember one thing, numerator as well as denominator, both are positives. Do not by heart that stupid formula in your textbooks, minus of V2 minus V1 divided by U2 minus U1. That is horrible formula. Please don't by heart that formula, guys. You will not remember it. Where was that minus? What is the sign convention? Why? Relative speed. I just told you, right? How to calculate relative speed. Just remember that. And remember, for elastic collision is 1. For inelastic collision is less than 1. For perfect inelastic, where it sticks, okay, if it sticks, then is 0. This is what you should know. This is what you should know. Excelente, excelente. All right. Oops, what is this? Okay, next, SHM. We have come to SHM, guys. Very good, very good, very good, very good. Kirito is missing Pandu, Champan, Laddu. Oh my God. Let's see all the equations of SHM. I'm going to start writing it down. You also make sure you keep the notes flowing. X is equation of SHM. A sine omega t plus phi. Remember this. A is amplitude. Omega is angular frequency. Phi is phase constant or initial phase angle. Differentiate it, you will get velocity. It is a omega cos omega t plus phi. Should you always start with sine? No. Can I use a cos? Yes. What will be the difference if I use a cos? Then when you differentiate it, velocity will not be cos, it will be minus sine. That's the only difference. It's okay. Next, acceleration is minus a omega square sine omega t plus phi. Next, a omega is max speed. It's the max speed of that particle. A omega square is the max acceleration of that particle. Keep all these things in mind. Next formula, which is there on your screen, is this. Velocity. Instead of time, I can also have x. This is very important formula. Omega root a square minus x square. Velocity in terms of x. Here velocity was in terms of time. Here acceleration is in terms of time. Acceleration in terms of x minus omega square x. Another important form. Okay, keep this in mind. Shall I remove this? Okay, next up. Yes, Bhargav, on Saturday we are going to revise it. Okay, now Veligula, I also covered rigid body mechanics at the beginning of the class. I am not sure if you missed it. right? So I compared translation and rotation, angular momentum, etc., and all those stuff. All right, cool. Next up, very important, differential equation. M, second derivative of x with respect to time, plus kx is equal to 0. This is called as the differential equation of SHM. Very important. And in a SHM, force is always proportional to x, but direction wise it is always negative. So you can say F is minus kx. So anytime you want to prove something is SHM or you want to find the time period, somehow show net force is proportional to x. And even if there is a constant, it doesn't matter. This constant does not affect time period. Okay, this constant does not affect time period. In fact, time period is 2 pi under root m by k, where omega is 2 pi by t or just root k by m. All these are important formulas from linear SHM. Very good, Shreyas. Very good. You will. Why not? With all our support and all your hard work, definitely you will. Yes. Phi is epoch angle. Nipun, well, different books call it differently, but in JEE we generally call it as the phase constant or initial phase angle. Okay, cool. Next up, very important stuff. Springs in series. Then equivalent spring constant is springs in series is 1 by k1 plus 1 by k2. Springs in parallel, very important. Springs in parallel, the formula is k1 plus k2. It's exactly opposite to that of resistors. Look at that, exactly opposite, like how you would solve in resistors. Keep this in mind. Okay, next up, angular SHM. Very similar formulas. You should remember two major formulas. For number one, for a simple pendulum. For a simple pendulum, the formula is 2 pi root L by G, and time period for a physical pendulum is 2 pi under root moment of inertia by mgd. Now you'll be like, sir, what is this d? This d is distance from hinge to center of mass. Keep this in mind. This d is the distance of center of mass till the hinge. And if you use moment of inertia for a simple pendulum, etc., in fact, you can derive this formula from this formula. It's very easy. Keep this in mind. Yes, very good, very good, very good, very good, very good. Yes, I hope this is clear. Okay. Then the only difference in angular SHM problems is, instead of force is equal to minus kx, the only difference is you have torque is minus k into theta. This is your torsional constant, and just like you had time period is 2 pi under root m by k. So instead of mass, you will have moment of inertia, and instead of k, you will have this torsional constant. That's the only difference. Symbols change, methods are similar. Very, very important. Okay. Then another important thing in SHM, which I wanted to give, energy of SHM. Energy of SHM is half k a square, and this is total energy, please understand. And this total energy is kinetic energy plus potential energy. Remember, potential energy is always half k x square and kinetic energy is half m v square. Keep this in mind. Very, very important stuff. Total energy will remain constant. It will keep getting converted from potential, kinetic, etc. Okay, cool. This is a one-shot slide for your phasor diagram. Remember what is a phasor diagram? Yes, Venkata Reddy, Bapuram, you can definitely crack, man. Who told you you cannot crack? If somebody has told you that you cannot crack, then they are lying to you. They are just trying to demotivate you. You will crack. Go with that spirit. You will crack. There's still some time left. Yes, Karthik, these formulas are also for JEE, because SHM will remain SHM, right? In JEE, it won't change. Velocity won't say, no, for JEE, I am going to be acceleration. Oh, acceleration? No. For JEE, I'm going to be force. No, obviously not. Okay. So, phasor diagram. The projection of a circular motion gives you SHM. The projection. So, if you are here initially, the projection will be here. As you move here, you will see the projection will keep shifting, and so you will see that particle on x-axis performs SHM. This thing which rotates is called phasor. The length of the phasor is amplitude, also the radius of the circle. The speed with which it rotates angular wise is angular speed in UCM, but in SHM it is called angular frequency. Symbols are same. The angle which this radius makes with reference line is initial angular position in UCM, but in SHM it is in fact called as the phase constant. Very important. Yes. So what is phasor diagram, Shamla Shetty? It's a diagram which helps us solve problems, number one. Number two, any particle which performs SHM, you can visualize a hypothetical circular motion whose shadow is this SHM. That hypothetical visualization is that phasor diagram. In depth, I have taught it in the playlist. You can check it out of SHM. Okay. Okay, cool. So I hope, Funny Kumar, that also answers your question. Welcome, Aman. Welcome to the Minion family. No problem, Asta. If you have not studied SHM, then just give it a skip or try to understand, guys. There is still time. Believe me. If you have that spirit, you will sit today, tomorrow, and try to understand from the lectures which I have conducted on SHM. Believe me, you can still do it. Try it. You never know. You might get some problem. Next up, in SHM, remember, if you force something, it vibrates, and there is a particular frequency with which you can vibrate. It oscillates with a large amplitude. That's when it's said to resonate, and the amplitude is very large. So if any spring mass system, any pendulum, anything has a natural frequency, we just saw it, root k by m, etc. If you oscillate it at a particular frequency externally, that amplitude at which it oscillates with a large amplitude, that frequency at which it oscillates with a large amplitude, that is the natural frequency. That phenomena is called as resonance. And if there is no damping, the amplitude is infinity, but reality has damping. So because of which the amplitude is not infinite, but it is large, like you can see here. Yes, Atharv, good bole. This is also for 12th standard. Looks like Atharv, you are from Pune or Mumbai. Kasakai Barahai, I am Mumbai. Alright, let's get going. Okay, so hydrostatic pressure. Let's go to fluids slowly. Come on, guys. Let's go to fluids. Yeah? Okay, cool. Pressure at some liquid surface, if it is P0. If you go inside the liquid, it is P0 plus rho of the liquid GH. But if you go up, it is P0 minus density of the air GH. Be careful. Go down, liquid density. Go up, air density. And the rate at which the pressure changes, this is called as pressure gradient. Variation of pressure with height. This is called pressure gradient, and this is minus rho g. Minus sign says that pressure decreases with height. Rho is density, g is gravity. This is only dependent on the height, depth, and the density. Please keep in mind, if you go like this or like that, pressure does not change. Keep this in mind. Yes, pressure gradient. Okay, next up, manometer. Difference in the pressure. If two levels are different, then just see the height difference. Then that height difference will give you the pressure difference using this formula. Pressure difference is rho GH. Also keep one thing in mind. I have told you one trick. Even if there are multiple liquids, keep this trick in mind. Always start from below. Pressure of E and F are equal. Why? Else the liquid will flow. Next, C and B pressure are equal. Next, A and D pressure is not equal. Why? They are in two different liquids. So, EF equal, BC equal, AD not equal. Keep this in mind. But understand pressure of D and C are roughly the same because this is air, and in air the variation is negligible. Okay, next up, Barometer, what is it used for? Measuring atmospheric pressure. What is the formula? Rho GH. What do you need to do? Take a tube, put it inside water or any liquid, start pulling it up, you will see a gap. Measure that height. That height will give you the atmospheric pressure. Is that clear? Very good, very good. Yes, my tech, I have uploaded all the formulas in something called as extracts. Do you guys know about extracts? No. I'll tell you, every lecture, or rather I would say every chapter that I have conducted over here on Enthuse, after every chapter, at the end, in the description box, you will see something called as extracts. What is this extracts? Is the complete summary which I have written, or a complete summary of the entire chapter with definitions, formulas, concepts, some important stuff in that, values, everything is there. But today I'm making you see all this because I want you to practice with me. This session is to practice with me so that everything gets into your head. Yes? Cool. Let's get going. Buoyancy. So whenever a body is in liquid, it experiences upthrust, opposite to gravity. This buoyant force will make you feel lighter, and the value of this buoyant force is exactly equal to, for example, if you have a mass, it's in air, it weighs 5 kg. You dip it inside water, you will see it weighs less. Oh, it's showing 3 kg instead of 5 kg. Oh, you can see a reduction of 2 kgs out here. That reduction of 2 kg force has come because of the buoyant force upwards. And if you just measure how much liquid was spilt in a container and you measure the mass of that liquid, that will be exactly equal to 2 kg. So the loss in the weight is exactly equal to the weight of the water or fluid displaced. Buoyant force, density of liquid into volume which is submerged into gravity. Keep this in mind. Very good, very good, very good, very good. Excelente guys, excelente, excelente. Continuity equation. Whenever a jet stream becomes narrow, especially when you are gardening, you will see when you press that pipe, speed increases. Equation of continuity. A1 V1 is A2 V2, and keep this in mind. Keep this in mind. This is rate of flow. Rate of flow is area into velocity, and the rate of flow has the unit of meter cube per second. Meter cube per second. Very important. Okay, rate of flow. Last up in fluid dynamics, remember, yes, Bernoulli's principle. If you have a pipe, doesn't matter how it is, bottom to top, top to bottom, any shape, doesn't matter. You have a pipe, velocity in is V1, pressure inside when it is entering is P1, when it goes out, speed is different, V2, pressure over there, different, P2, and this is at height H1, the out cross section is at height H2 from some reference line. Always take a reference line. Remember, in Bernoulli's equation, do not start without the reference line. Then pressure plus rho GH plus half rho V square is constant. This is called, do you know what is this called? This is pressure energy. This is pressure energy per unit volume. I have told you this. What is this? This is gravitational potential energy. Okay, per unit volume. What is this? This is kinetic energy per unit volume. So pressure energy per unit volume plus potential energy per unit volume plus kinetic energy per unit volume is conserved initially and afterwards. That's how you can remember this. Correcto. Some of you got it. Very good, Shadvika. Kya baat hai? Tanmay, how will you get KVPY? Why you did not register, or are you scared? Don't worry, beta. Don't worry. आप तो ओके कूल, रटे हुए कॉन्सेप्ट भी बता रहे हो, कहाँ बता रहे हो, मतलब आई एम नॉट एबल टू अंडरस्टैंड तन्मय, कैन यू बी लिटिल बिट क्लियर? ओके, एंड इफ यू स्टिल हैव सम कॉन्सेप्चुअल डाउट तन्मय बेटा, डोंट वरी, इन डेप्थ chapter formulas etc, application of problems I have conducted. Whichever chapter you are doubtful at, please watch the replays beta. Okay, अरे क्या बात है निरुपम, नागपुर कैसे हो? Tilankhadi Lake, Haldirams, oranges. Very nice. I love that city. Torricelli's law. Next up, formulas are very important. Velocity is root 2 gh, but keep this in mind. What is h, etc. So if this is the container, if this is the hole, this is the velocity, this is that height, small h. Please keep this in mind. And if this is h1, okay, this is h1, not the complete one. Complete height will be h plus h1. Then the range, okay, the range is, be careful, 2 root h1. Very important. Last thing important over here, if you drill a hole here and if you drill a hole here, the range will be same provided this and this are equidistant from the center. Yes, or from the ends. So if you drill a hole here, it will fall here. If you drill a hole here, it will fall here. If you drill a hole at the between, it will fall at the maximum range. So for complementary distances, if you go here, here, range is same. Here, here, range is same. At the center, range is maximum. Keep this in mind for solving problems. This is a range formula, Torricelli's law. Okay, cool. Yes. Okay, cool. Let's get going. Let's get going. Cool, 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 cool. Let's get going. VK channel says ready. Oh, okay. So tendency to reduce surface area. What is it called? Surface tension, like bubbles, water on a surface, or anything which always has a tendency to contract. It always feels that it has to reduce the area. Why? Because molecules do not like to sit on the surface. So they will always tend to contract. Very important. And S is surface tension. Depends on the liquid temperature, impurity, etc. L is the length on the surface on which the surface tension acts. Force of surface tension is S into L. Unit of S is Newton per meter. And remember, very important, a lot of people make mistakes. If you have a rod, okay, then if there is a film here, then the force of surface tension is 2SL, not SL. You'll be like, sir, there is only one length, why 2SL? Guys, I have explained this. There are two surfaces, one in the front, one in the back. So that's why 2SL. Keep this in mind. So this is the side view. So you will see that there are actually two surfaces when you look at it from the side. This is the view from here. If you see that rod, there is one surface below, one surface on the top. So 2SL. And remember this formula, useful for calculation of how much energy is lost, gained when drops combine or expand, etc. USA, potential energy per unit area, is SA, surface tension into area of the surface. Thank you, Aman, so much. Okay, cool. So remember this. So wherever there is change in area, use this formula to see how much energy has been liberated. Use this formula for balancing of forces, Newton's laws, etc., acceleration, etc. Use this. Then I have given you one more formula. Any curved surface will have a pressure difference. Obviously, if the surface is flat, then here and here pressure is same. But if the pressure increases here, it will bend. Pressure on concave is more than pressure on convex. If this pressure is more, it will bend like this. So pressure on concave is always more than pressure on convex side. And how much is the difference? 2S by R. When there is one surface, meaning there is air outside, liquid inside, or air inside, liquid outside. So there is only one surface. But it will be 4S by R when there are two surfaces. That is, there is a film, there is air inside, air outside. So you can see there are two surfaces. So it will become 4S by R. What is our radius of curvature? Keep this in mind. Sadhvika, I'm very good and I'm feeling very tired. My voice is going to stop, I think. But I'm not going to give up. So guys, come on, show some josh here. And I want you to really spread this video to all your friends, all your relatives, all your cousins, all the important people in your life. And share this video. Come on, show some support here. I'm doing all this for free of cost for all of you. Okay. And the only reason I want to do is because I really want you to crack this examination. And this is a last minute revision session that I have planned for all of you. And I really want to make sure that every minion out here does get at least one question more because of this session. Even if you get one question correct because of this session, I'll be, trust me, the happiest man on earth on the day of the examination when you're going to write it. Okay, Next question, capillary rise. When you take a liquid like water, it rises in a small tube. When you take a liquid like mercury, it goes down in a tube. Liquids like water in glass have acute angle of contact. Liquids like mercury have the convex side up, so they have obtuse angle of contact. Acute angle of contact is when the liquid sticks to the walls of the container, so it rises up. But obtuse angle of contact is when the liquid does not like the solid, so it goes down. That's how it works. And the formula is 2s cos theta by rho g r. S is surface tension, theta is angle of contact. You can see this is angle of contact. And if theta is 90, for example, water in silver, it makes flat surface. Cos 90 is 0. There is no rise, no fall. Keep this in mind. Also, thinner the capillary, higher is the water in that tube. More the density, less the height. Keep this in mind. Okay, 2s cos theta by rho g r. Next, viscosity. 3 important formulas in viscosity. Shreyas, you will get PDFs of this session as well. You will get it. It will be there in the description box as well as the Telegram group. Go join the Telegram group. It is there. It will be there in some time. Okay, definitely Shreya, I'll be uploading. Yes, Newton's law of viscosity. But remember, not everything will be there because whatever I write on the board will not come in the PDF. So please keep that in mind. Force is eta a derivative of rate of change of velocity with layers. Velocity gradient. Eta is viscosity coefficient. A is area of contact. How quickly the velocity changes with layers. That is this derivative term. Next up, for Stokes' law, use this formula only for spheres, nothing else. 6 pi eta r v. What is our radius of the sphere? What is v? Velocity of the sphere. What is this drag force? This force opposes velocity. Using this formula, you get the terminal velocity. So when you drop a solid of density sigma in a liquid of density rho, the final speed with which it comes down is 2 by 9 gr square, difference of density by eta. Very important formula, terminal velocity. These are the only important formulas out there. Oh, thank you, VK. I'll just drink some water. Just hold on. I'll just drink some water and come. Okay, come on guys, let's get going. Come on. Let's get going. I hope you have noted this down. Next up, in one slide I will tell you everything about elasticity, shear, longitudinal and bulk. Very important. First, longitudinal. Stress is the force which is perpendicular to the surface, perpendicular, divided by area. Strain is change in length upon original length. Young's modulus is that stress by strain. Same thing, if you apply force parallel, it bends. So shear stress is that parallel force by area. Shear strain is tan theta, that angle which it makes, which is delta x by L. And rigidity modulus or shear modulus is that stress again by strain. Same thing. Bulk modulus, stress is change in pressure. Be careful of this delta, it's not pressure, change in pressure. Strain is change in volume upon original volume, but be careful, bulk modulus is minus delta P divided by delta V by V. Why that minus sign comes, I have explained in the video of elasticity. You can go check it out after the class, but this is very important. Okay, so all the formulas are there over here. Next up, energy. Elastic potential energy is half stress into strain, number one. But this is potential energy per unit volume. Be careful about it. This is elastic potential energy per unit volume is half stress into strain. And if you remember, just elastic energy I can write it as spring energy, which is half k x square. So if you want to write it like this, I'll tell you what you can do. Elastic energy not per unit volume, but just energy. Then this x is just extension. This is just the extension. This k, which is the equivalent spring constant, is ya by original length. Yes, you can convert a rod into a spring, and that equivalent spring constant is given by ya by L, useful for solving problems. Write this down. Write this down. Very, very important. Okay. Next up, stress strain curve. Please download the stress strain curve or watch it properly in your NCERT book. Okay, I can keep drawing it over here and show you everything, but please observe that stress versus strain curve. Very, very important. Stress versus strain curve in your NCERT. There will be questions on this. You never know. Okay. Next up, thermal physics. Let's come to thermal physics. First of all, coefficient of thermal expansion. Change in length is original length into alpha into change in temperature. This alpha is called coefficient of thermal expansion, depends only on the object. Same formula for area expansion. How much does the area expand? Change in area is original area into coefficient of areal expansion into delta T. Same thing, volume expansion. Change in volume is volume into gamma into delta T, and all these variables are related by this relationship. 2 alpha is beta. So area is twice alpha, volume is thrice alpha. Remember this. And you should be able to convert from Fahrenheit to Celsius, Kelvin to Celsius, and all that stuff. So this is another important formula which you should know. Keep this in mind. Hello Kashish. Hello, love you Babu. Anil, I'm not sure. I mean, you should ask to Shimon sir and Wazim sir. For sure, they will be doing something like that. Okay, cool. Hello, Tavish. Okay. Now, next up, calorimetry. First of all, remember all these definitions. Heat capacity or specific heat capacity is the amount of heat required to increase the temperature per kg or per unit mass by 1 unit of temperature. That's specific heat capacity. Then latent heat is the amount of energy to change the phase. So some important formulas which will be out there will be just 1 second. Yeah, you'll have Q is equal to mc delta T. That's one formula, but this m into c can be written down as capital C. Please understand, this C stands for just heat capacity, and this small c stands for specific heat capacity. Keep this in mind. Next up, latent heat. Q is equal to ml. Standard values, remember, latent heat of fusion for ice is 80 calories per gram. And latent heat of evaporation or vaporization is 540 calories per gram. Standard. C for water, standard, you should remember 1 calorie per gram per degree Celsius. This is also standard. All these values you should remember. Keep writing it. Thank you, Chika's Freak. Thank you. All right, let's get going. And most important principle of calorimetry, heat absorbed by colder bodies will be heat released by the hotter bodies. Equate the two to get the final mixture's temperature. Nothing will go out, nothing will come in, they will exchange. So use these two things to find the final equilibrium temperature. Now, KTG, very important. I will not write it down here, but please watch or read the entire assumptions of kinetic theory of gases either from H.C. Verma or from your class notes or from NCERT. Very important. Each and every assumption in kinetic theory of gases. Do that. Okay. Now, this is the best table. Everything consolidated in one chart. Whether it is monoatomic gas like helium, argon, or diatomic gas like hydrogen or oxygen, or a polyatomic gas maybe like carbon dioxide or something like that. Okay, so all these things are mentioned over here. Internal energy, degrees of freedom by 2 RT. What is degrees of freedom? How many degrees independently it can move, alright? So for mono it is 3, for dia it is 5, even for linear atomic like carbon dioxide. Carbon dioxide is a linear triatomic molecule, degrees of freedom 5. Polyatomic non-linear could be something like methane gas or something like that. That would be having 6 degrees of freedom. So 3 by 2 RT, 5 by 2 RT, 3 RT, all these are CV values also are there, and CP values which are more than CV by 1 R. The ratio of CP by CV is gamma. Also gamma is related to F. Use this formula, 1 plus 2 by F. If you have forgotten, 1 plus 2 by F gives you gamma. Keep this in mind. Very important table. Write it down. Try to write it down on your own. Every bit of it. Only write down left hand side, right hand side on the top, and start filling up the table. Very important. Very important. Yes. Tathagapal, I think it will be of the same level. It won't be tougher or it won't be easier also. I think it will be of the same level. Don't worry, beta. Okay? Don't get scared. If somebody has told you it will be tougher, they are lying to you. Bandari NEET aspirants can also see my videos. Olympiad aspirants can also see my videos. No problem, beta. Because physics is the same. It doesn't change. Only the nature of the questions will change. Okay? Okay, cool. Let's get going ahead. All the important formulas of thermodynamics in one slide. Possible. Yes. Every process is there over here. Isochoric, isobaric, isothermal, adiabatic. Gas law relationship. What is constant, what is not constant. Like for example, isothermal PV is constant. For isobaric, since pressure is constant, volume is proportional to temperature. Work done, 0 for isochoric. For isobaric, P delta V. Isothermal, nRT ln V final by V initial. Heat, for adiabatic, obviously 0. Alright, and other stuff. And same thing, change in internal energy. Please keep certain things in mind. First law of thermodynamics. First law of thermodynamics. Heat is delta U plus work. Very important. This is in physics. In chemistry, work goes there. Keep this in mind. So if you know any two, you can find the third. Any two you know, you can find the third. Keep this in mind. Okay? And remember one thing, change in internal energy always is NCV delta T. Always. Always. See, isothermal, 0 because delta T is 0. Yes, for everything else it is always NCV delta T no matter how you do it. Very, very important. Alright, thank you. Steady state heat engine. Rishi, that's your, from second law of thermodynamics. Not many problems come from that, but still if you want to know about it, I can just tell you the formula. See, it's nothing but efficiency. Oops. Remember this. Efficiency of an engine is 1 minus smaller number by bigger number. Smaller number is cold temperature, hotter is T hot. And this is always output by input. So output is the work and input is heat absorbed. Remember this formula, that's it, you're sorted for engines. Okay? Efficiency of an engine is 1 minus colder temperature of the engine upon hot temperature of the reservoir. And this is always efficiency is output. Output is work. Input is heat which is absorbed. That's all you should remember if at all you want to solve any problem for now. In detail, I will cover thermodynamics later on. Don't worry about it. Next up, heat conduction. Rate of heat flow. Q rate. Q rate is nothing but dq by dt. Is Ka dt by dx. Very important. Okay, or some people also prefer to write it as Ka hot temperature minus cold temperature divided by length. One and the same thing. This is dq by dt. Now, some people also write dq by dt as heat current. Heat current. This thing over here, they write it as temperature difference. This is temperature difference. Now think about it. If you compare it with V is equal to IR, voltage difference is current into resistance. Think about it. This is temperature difference, voltage difference, heat current, resistance, that means this term. Yes, this term inverse. So thermal resistance is L by Ka, because when you take it over there, it will become L by Ka. So this is thermal resistance. So you can use all the theory of current electricity for solving these problems. Yes, you can use all the theory of current electricity. Keep this in mind. Yes, this is only for steady state. Yes, this is only for steady state, and you don't have unsteady state in JEE. Don't worry about it. Okay? Unsteady state is not there. Next up. Yes, rotation comes, Chaitanya, in SA stream. It will come. It will come. Next up. Keep this in mind. Okay? Radiation in one slide. Yes, I will teach you. I'll tell you how. Incident radiation. Let's say energy incident is Qi. Let's say energy incident is Qi. Let's say reflected energy is QR. Let's say reflected energy is QR. 100 joules is incident on some object. Some part gets reflected. Some parts get emitted. Oh, sorry. Why is this emitted coming over here? This should have been transmitted also. Should have been there. 1 second, guys. Yeah. Transmitted should also have been there. Some energy gets incident. Okay. Out of that, some gets reflected, like from a mirror. Some passes through it. So let's say that energy which is transmitted is QT. Some gets absorbed within it. So that is QA. Then remember this. Energy which is incident is nothing but energy which is incident is energy which is reflected plus energy which is transmitted plus energy which is absorbed. Yes, very important. Why am I putting a dot over here? This is because it is dq by dt. That means it is joules per second unit wise. That's why I'm putting a dot over there. Keep this in mind. Next up, these ratios. Absorption is Q which is absorbed upon incident. Reflection coefficient, Q which is reflected upon Q which is incident. And transmission coefficient, Q which is transmitted upon Q which is incident. And since this is this plus this plus this, A plus R plus T is also 1. Keep this in mind. Keep this in mind. So some light falls on it, some gets reflected, some gets absorbed, some gets transmitted. The coefficients, sum is always 1, and a body will also emit radiation separately. See, this was external factors. Something was incident, it gets reflected, etc. But independently, it will also emit something, and that energy which is emitted is given by E sigma A T raised to 4. What is sigma? Stephen's constant. What is the value of Stephen's constant? 5678. Remember this, 5.67 into 10 to the power 8. Keep this in mind, guys. Okay, so that's it. And E is what? Emissivity. What is E? Emissivity. So E is 1 for a black body. For a black body, emissivity is 1. Keep this in mind. Yes, for a black body. And also remember Kirchhoff's law. Kirchhoff's law says that. Yes, Kirchhoff's law says that. Okay, E is equal to A. Very important. This A over here is always equal to this E over here. Keep this in mind. Keep this in mind. A and E are always equal, Kirchhoff's law. So guys, keep this in mind that the net rate at which heat gets entered into the body, net heat, is heat which is absorbed minus heat which is emitted. Heat which is emitted. Something is getting emitted, something is also getting absorbed. So it will be basically A sigma A T raised to surrounding 4 raised to 4 minus E sigma A temperature of that body raised to 4. please keep in mind, whatever gets absorbed, all right, whatever gets absorbed depends on the temperature of the surrounding. Because where is it absorbing from? It's absorbing from the surrounding. So this is why surrounding temperature will come. Emitted, where is it happening? It's happening because of the temperature of the body. Please keep this in mind. Since A and E are equal, that's why when you combine them together, it will become E sigma A T raised to 4 minus T raised to 4. This is how you get it. This is how you get it because of Kirchhoff's law. Keep this in mind. Okay, I hope this is clear. Cool. Newton's law of cooling, very important, guys. Yes, rate of cooling. Rate of cooling. Yes, rate of cooling, which is dt by dt, is some constant into temperature of that body minus temperature of the surrounding. This is what is important. Rate of cooling is constant, some constant into difference of the body's temperature and surrounding temperature. So graphically, if you draw a tangent, the slope is nothing but rate of change of temperature. This is temperature versus time. So rate of change of temperature is that slope, which is dt by dt over here. That is proportional to how different is the temperature of the body with the surrounding. Very important law. Keep this in mind, will be helpful for solving problems. Okay, cool. Last part of today's lecture. Are you guys ready? Are you guys ready? Last part. VK channel, I'll tell you on Instagram, yeah. Okay, don't worry. Okay, chalo. See, basically there are 3 laws like Charles' law, Gay-Lussac's law and all that. In each law, one thing is constant. Okay, don't worry, VK channel. Yes, VK channel, don't worry, I'll tell you, don't worry. Yes, Shreyas Pandey, I do know you. You are a student from my topper batch. How can I forget you? And plus you share my name. Okay. Transverse wave and longitudinal waves formulas are same, so we'll do it in one slide. Let's do this. First, for any wave, for any wave, transverse wave, the equation is A sine kx plus or minus omega t. Okay, phi can be there, but let's ignore it. For longitudinal wave also, the equation looks like this: Sm sine kx plus or minus omega t. Now keep this in mind. If it is plus, then it is going in the minus x-axis. If it is minus, it's exactly opposite. It's going in the wave is going in the plus x-axis. Same thing works over there also. Okay. Next, what is this y? This is your wave, right? So this y tells you basically your displacement in y direction. When that wave is going like this, what is that? Displacement in the y direction. What is this s? This is longitudinal. The particles are going like this. This is displacement along, or displacement from the mean position. Mean position, very, very important. Okay, what is this A? This A is the amplitude, maximum y, basically max value of y. Here Sm is max value of S, all right, which is also called as the displacement amplitude. Very, very important. Next up, what is this K? It is 2 pi by lambda. Unit is radian per meter, and this is called as angular wave number. Same thing, same K over there here also. and omega is 2 pi f. This is angular frequency, unit radian per second. F is just in hertz, normal frequency. Keep this in mind. Keep this in mind. All right, I hope this is clear. Next up. Okay, next up. Wave velocity is omega by k. Omega by k. Or you can also write it as f into lambda. One and the same thing, because omega is 2 pi f and k is 2 pi by lambda, that 2 pi cancels and you will get this. Okay, all these things work. Always remember, okay, now once you know this, always remember the medium decides the velocity. The medium decides the velocity. The source who is talking decides frequency, and both of them together decide the wavelength. So if you are ever confused, okay, what happens when velocity changes? Will frequency change or wavelength change? Remember this flowchart, you will never get it wrong. Source decides frequency, medium decides velocity, both of them decide wavelength. By that formula, V is f lambda. Keep this in mind. Okay, next up, velocity of a transverse wave, like you can see, it depends on the medium, root tension of the string divided by mass per unit length. So this is kg per meter. This is tension, it is in newtons. Longitudinal wave, it depends what you are talking about. If it's a solid, it is root of, very similar, you have Young's modulus and instead of mu you have density. This is kg per meter cube. Remember, this is Pascal, Young's modulus. But for a liquid, it becomes bulk modulus by density, very important. And for a gas, it becomes, what does it become? It becomes gamma P by rho, or you can also write it as gamma RT by molecular weight. This is only for an ideal gas, very, very important. This is for longitudinal waves traveling speed. Yes, very good, very good. Very good. Chalo, next up, power, average power transmitted in a wave which is transverse, half mu V A square omega square. Longitudinal, average power transmitted is half PM square by rho V. Now you'll be like, what the hell is this PM? This PM is called as pressure, amplitude, and PM is always BKSM. So when particles vibrate, they have displacement and pressure also varies. SM is the maximum displacement of that particle. PM is the maximum pressure variations in the medium, and they both are related to each other. What is B? Bulk modulus. What is K? 2 pi by lambda. Do not forget that. This is bulk modulus. And what is K? This is 2 pi by lambda. Very, very useful formula for all of you. Yes, correct. Remember all this. Next up, interference of waves. So two waves, now this is same for both of them, in the same phase. Then they produce a longer wave, or sorry, a taller wave, that is called constructive interference. If this is A1, this is A2, this amplitude will be A1 plus A2. This situation is said to have no phase difference. They are said to be in phase. Yes, they are said to be in phase. But the same thing, one is like this, the other one is like this. This is A1, this is A2. If you add them, you will get a smaller wave of amplitude, whichever is bigger minus smaller. That interference is said to be destructive, and the phase difference is pi radians. They are said to be out of phase. Crest with trough, trough with crest. Keep this in mind. Next, if one is like this, other one is like this, there is some difference. There is some difference between the two, but it's not exactly matching. Then the resultant So when you add them, will be also a wave, but the resultant amplitude will be just like the vector formula, a1 square plus a2 square plus 2a1 a2 cos del phi. What is this del phi? Phase difference. Phase difference. And what is this phase difference? Phase difference is 2 pi by lambda delta x. 2 pi by lambda delta x. Keep this in mind. Yes, very good. Keep this in mind. Okay, I hope this is clear. I hope this is clear. Yes. Next, yeah, this is how you relate both of them. Okay, very, very important. And you can also remember the power formula. The power of the resultant wave is P1 plus P2 plus 2 root P1 P2 cos del phi. Power formula for adding of two waves. Very, very important. P1 plus P2 plus 2 root P1 P2, because remember power is always proportional to amplitude's square. Very important. The power of any wave is square proportional to the amplitude. Okay. Now one last thing. If you have a crest and it gets reflected, okay, so you have a crest and it gets reflected from a solid support, then after reflection the wave is inverted for a solid support. But the same wave, if it is incident on a free support, this ring can move up and down, then when it gets reflected, you will see it will come back as a crest only. So this is for transverse, very, very important. Similarly, in longitudinal, if you have a compression, okay, so imagine you have a compression which is incident on a rigid wall, okay, then the reflected pulse is still a compression. This is very opposite. See, in a transverse wave, crest comes back as a trough, but in longitudinal, compression comes back as compression from a rigid support. And another important thing, if compression gets reflected from a free end, then it comes back ulta, exactly, as a rarefaction. This is how things are different. Yes, correct. Very good, very good. Okay, now there is one thing which is similar, and that is if you have if you have a string which is fixed at both ends, this is similar to a pipe which is closed at both ends. And the formula for frequency of standing waves which can be produced is given by NV by 2L. NV by 2L when it is fixed at both ends. But if one end is fixed, one end is free, okay, that is same as one end being closed and one end is open. And then the formula is odd multiple of V by 2L. L is the length of the pipe or the string. Very important. And if you have two free ends, which is same as a pipe which is open at both sides, the formula is same as the first one. So it is F is NV by 2L. Keep this in mind. Very, very important. I hope this is clear. I hope this is clear. Yes. So this chart will tell you everything about standing waves produced on a string or standing wave produced in a pipe. This will always help you for solving problems. Guys, these are in short formulas which I am giving you. Correct. And yeah, I think that's about it. Yes. So guys, we have almost revised I think 99% formulas. Maybe one or two formulas might be remaining here and there. But I think most of the formulas, 99% are almost done. So guys, 28th January, please keep in mind, crash course starting for all of you guys. And why am I telling you today about all of this? Because there are going to be lots of sessions, doubt solving, papers, discussions, doubts inside the class. And there is an offer going on right now for 7,000 rupees. 30% off. Usual offer is 20%. Today the offer, because of the Republic Day, it's not 20, it's 30%. And this offer will go off tomorrow. Tomorrow will be the last date because day after tomorrow, the batch will start. So the coupon code is SHCC21. I hope you appreciate my efforts, and I hope you use this coupon code, and I hope you will recommend this video, this channel, this coupon code, this link for all your friends and relatives or cousins who will be interested in this coupon, crash course out there. And every detail about the next session, the upcoming sessions, the PDFs of this session, etc. will be posted on the Telegram group. So do not forget to check it out in the description box below. Alright, and I hope you have already liked the video and subscribed to our channel. Have you guys enjoyed today's session? No, I will not forget to answer you, don't worry. But give me some time, by tomorrow morning I'll answer you. Sri Lakshmi will definitely come up with a course for class 10th very soon, after April. Once your board exams are over, we'll come up with a course. Yes, we'll come up. Sri Lakshmi, don't worry, we'll come up. Alright. Thank you, Shreyas Crazy Studio. Thank you, Yalni, Joel, VK, and everybody, Dinesh. Yes. Yes. Nothing now, Sri Lakshmi. It's too early to prepare. Don't worry. Enjoyed a lot, Dan. Very good. Very good. Thank you guys very much. Bye-bye. It was an amazing session. Now my throat is gone, and I'll see you tomorrow for a special session on Republic Day. So stay tuned. Thank you for all the support, all the love you guys have given. Have your dinner. Even I'm also going to head out and have my dinner now. Bye-bye. Take care and keep learning at Enthuse. This was Shreyas here, your master teacher for physics. See you tomorrow at the time which will be mentioned in the Telegram group.